Hello everyone, I would like to talk about why swak4Foam is important for us and when we should use swak4Foam. Look at here. As you can see, swak4Foam gives you a lot of possibility without knowing programming in OpenFOAM. You can customize a lot of OpenFOAM utilities and gain additional features without knowing anything about the C++ or programming in C++. For example, if you want to apply a new boundary condition, you can use groovyBC or funkySetField. If you want to apply initial conditions instead of OpenFOAM setField utility, you can use funkySetField. Or when you want to do runtime processing instead of post-process, or function objects, you can use a swak version, swak function objects and simple swak function objects. Even though for post-processing, you have the post-process, or in some versions of OpenFOAM, you have foam calc. Instead of that, you can use funky do calc in swak4Foam. And another feature which is important in swak4Foam, you can use Python code directly in OpenFOAM simulation runs with Python integration features in swak4Foam. So with Swak, you can do a lot of stuff without knowing any programming. Let's show it with a simple simulations how swak4Foam works. You already installed the swak4Foam. Now you want to know how it works. Consider a cavity. You have a velocity at the top wall, and you have a bubble in the cavity. First, look how to initialize the main to create a circular bubble. For that, you can use the utility in OpenFOAM called setFields. For example, you have a function called cylinder to cell. You can mention 2 points and a radius. With 2 points and a radius, you can create a cylinder. Inside the cylinder, the value of alpha would be 0, and the outside of the cylinder, it would be 1. So you can create a circular cylinder, a circular bubble in your simulation. Let's do it together. First, I copy okay, then using setFields and apply PowerForm. Yes. Also, maybe you want to, for example, have a box. For the box, you need to define the box and 2 points. The points in the diameter of the box should be given. Okay, you can see that you can set initial condition with a utility setFields dict, but the setFields dict, it is a simple, but it is useful for simple geometries like boxes, cylinders, spheres. You can apply some sophisticated initial condition using STL file, but it is hard. You need to create first STL file, then import it, and then use this setField method to apply boundary condition. An easier way to do that is using funkySetField. For example, you want to apply a cylindrical bubble using funkySetField. As you can see, you can use these functions. How it's work? Here you give the your field which you want to apply the initial conditions. Here you can define all the variable you like, and here the important part, you can define a expression or a function. For example, here I defined the formula for the circular cylinder. I said pose x return the position of the cells, and if the from this formula I calculate the distance of each cells to the coordinate, the circular center, and if this radius is smaller, the radius of the bubble I define, it's becomes 0, and greater than it would be 1. Also I said keep the patch 1, means don't change the boundary conditions. Okay, let's try how FunkySetFields work. It's similar to setField. You need to write FunkySetFields dash time 0. Okay, now you may say, okay, FunkySetField is not easier than setFields. Yeah, in the setFields you need to give 2 points and a radius, but here you need to give a full expression, but this expression gives you the flexibility to change it. For example, in the setFields, it's not easy to change the circular bubble to the oval bubble, but here it's easy. Let me show you. I add 2 other parameters, a and b, and change the expression. Here I wrote the expression for the oval. Now if I write the yes, now you have an oval. You can apply any initial condition you want with a FunkySetField. So it gives you a more flexibility than setField. The other important capability of the swak4Foam is for the writing in new boundary conditions. For example, here instead of the fixed value uniform 1 in an x direction, you want to write a boundary condition dependent to time. For example, it changed with this formula. Okay, so it is easy. You can use, instead of the fixed value, use a type groovyBC. groovyBC needs 3 parts: value expression, gradient expression, and fraction expression. The fraction expression defines which one of these is employed. If I consider fraction expression 1, value expression will be used, and if I consider fraction expression 0, gradient expression will be used. I can consider fraction expression as a number between 0 to 1. Also, I consider fraction for fraction expression, means I use both of the value expression and gradient expression together, considered as a mixed boundary condition. However, here I want to consider a value expression dependent to time, a function of time, so I consider fraction expression 1. And here in the variables part, similar to FunkySetField, I can define my variables, and in the value expression I can define my expression and function. As the velocity is a vector, I define a vector, and here the x component of the vector, which is defined based on the time. Just remember, groovyBC is not a OpenFOAM boundary condition. So you need to call it from the control dict. You need to add this line to control dict so you can use the groovyBC. Let's run and see how it's work. It takes a while to run it. Okay, and now we can see the result. As you can see, it doesn't remain axis symmetry because the velocity change in the, maybe here you can see better. Let me choose the X, and as you can see, the velocity changes from -1 to 1. That's it. Also, swak4Foam has other functionality like runtime processing, post-processing, Python integration. You can find a lot about the swak4Foam in these two addresses. There are a lot of resources for it. You can read it and add it to your simulation and make it your life easier.